period of time to answer audience questions. And then we're looking for volunteers who are interested in helping with the math, and you can sign up tonight. Okay, what is the math debate about? It is not about rote memorization versus flexible problem solving. It's not about teaching techniques, and it's not about algorithms versus conceptual understanding. It is about content. What is the difference in content? Here's one of the hardest fraction problems we could find in TERC math, which is being used in our elementary schools right now in Frederick County. There were 60 words on a spelling test. Nora spelled 2/3 of the words correctly. How many words did she spell correctly? Now, this is Unit 4 in 5th grade. Students were given 40 minutes and a partner to solve this routine problem. The TERC manual does not list multiplying 2/3 times 60 as a way to solve it, which is probably the way that all of you would think to solve that. Okay, what is the difference in content? Here is one of the hardest fraction problems we can find in Singapore math. Gopal spent 3/5 of his money in the first week and 1/3 of the remainder in the second week. He spent $110 altogether. How much money did he have left? And this is workbook B in the 5th grade. This is a multi-step problem that requires students to understand the math. Students taught with Singapore math can solve this without algebra. What is our math program? As you may have guessed, we will use Singapore math in grades kindergarten through 6th grade. We'll also use Glencoe's pre-algebra and McDougall-Patel's structure and method. Our guest speaker, who is also on the board of advisors for the school, will explain more about the math, how to solve our example problem, and why Singapore math is so well regarded. On the table inside here, we've got an entire kindergarten through 6th grade Singapore math series, the workbooks. There's some manipulatives there too that you can take a look at. Our pre-algebra text did not come in, although there is one that's involved in the series. It's just due to snow. Just, the truck couldn't get here. So we invite you to take a look at that when we have a chance a little later on. Okay, now who is Dr. W. Stephen Wilson? Dr. W. Stephen Wilson is a professor of mathematics at Johns Hopkins University. He's been chair of the Department of Mathematics. His 1972 PhD in mathematics is from MIT. He spent 8 months in 2006 as the Senior Advisor for Mathematics, Office of Elementary and Secondary Education, United States Department of Education, and was one of the co-authors of the Fordham Foundation report, The State of Math Standards 2005. He helped revise the Washington State K-12 mathematics standards and evaluate textbooks for the state. He has helped out with numerous smaller projects on standards, curricula, and textbooks. More recently, he reviewed drafts of the new Common Core Mathematics standards for the National Governors Association and the Council of Chief State School Officers, and is the author of the mathematics portion of the October 2009 Fordham Institute report, Stars by Which to Navigate. An interim report on Common Core, NAEP, TIMSS, and PISA. He has over 60 research papers in mathematics, specializing in algebraic topology. In other words, he's really, really smart. So, without any further ado, I will have Dr. Wilson come on up and continue the presentation. Thank you.
I think I should put one on the head. So, I've been asked to come and talk. Yeah. They didn't actually say that I should talk about all those things that they just said I was going to talk about, so I probably won't. But I'll say a little bit at any rate. So the message that I want to say is really simple. Arithmetic is really, really important. Singapore math does arithmetic and does it right. And that's the program, the charter school that's being proposed wants to use. So for those of you who believe that, you don't need to stay. I'm done with my talk. I'm just going to fill in a few details now. And in particular, I want to put it in a big picture. And the first part of that big picture is, why should I have any credibility with you when I say those things? Because that list of things didn't really give you a reason to believe that I should have credibility. So I'm going to make a case for me as someone that you should listen to. And maybe then you can believe what I say. So, I'm a research mathematician. Everybody has an image of mathematician, and it's historically not a nice one. I'm not going to ask anybody what their image is because I don't want to know. It's probably not something you say in public in front of your kids. So, but what I want to say is that your image of a mathematician is wrong. And I want to try to reshape your image of what a research mathematician or a mathematician is, so that I can gradually work your way over to the point where you can believe stuff I say. So, what is it that a research mathematician does for a living? Okay, while I prove new theorems, I write papers, I publish them in research journals, but as much as I do that for a living, it isn't enough. I have to do something else. If I were in France or Germany or Japan, I could get a job where that was all I did. But this is America, and we have an anti-intellectual tradition to live up to, and so that's not acceptable. I mean, there's a handful of people in Princeton at the Institute for Advanced Study that can get away with it, but for the most part, the rest of us have to do something constructive for society in order to be allowed to do our research. And what that thing is we teach. And we teach at all levels of colleges, from fancy universities to junior colleges, community colleges, all over the country. That's what we do for a living. And we, in theory, it's half our time doing research, half our time doing teaching, but in fact it's frequently more time spent doing teaching. And so that's where I'm going to try to change your image, but I have to do a little more than that, because I know that there are people in Frederick County, administrators, who have said that, oh, those mathematicians, yeah, they teach, but all they care about is creating more mathematicians. And maybe that's all we care about, but that isn't what we do, okay? What we do, let's face it, nobody majors in math. Well, almost nobody majors in math. So if nobody majors in math, we're not going to have a lot of students taking math courses their junior and senior year in college. The only people taking math are going to be freshmen and sophomores. And even the sophomores, it's only going to be people who are engineers, because they have to take 2 years of math. But the bulk of our students are freshmen in college. If you want to be a business major, you want to be an architect, you want to go to medical school, you want to be an engineer, you want to be a scientist, all of those people are taking freshman mathematics. So what is it a research mathematician does, and what is the appropriate image that you should have of a mathematician? We're 13th grade teachers. Okay? Now that fits into the spectrum of things you know about, right? It's just one more than 12th grade teachers. Except, of course, none of us are qualified to teach the 12th grade. I've been teaching the 13th grade for 38 years, since I got my PhD in 1972, and I'm still not qualified to teach the 12th grade. But that's what we do. And so, yeah, we do research, we go to conferences, we talk about our research, but then we go out to dinner, and what do we really have in common? You know, mathematics research is huge, and there's people who do all kinds of things that I can't talk to them about, but the one thing we can all talk about is our teaching and our students. And so when we go to dinner, and the conversation always gets around to talking about our students and their lack of knowledge of fractions and long division, and how we wish that they knew that stuff, and how we wish K through 12 would send us students who knew that stuff. And we really ought to have a say in what K through 12 produces, because we get them next, and we really do get them next. If you look at high school graduates in the United States, 80% of them go on to college.